Welcome once again to our online lesson. As you know, Math Made Easy with PDY. Now today we are going to continue with our lessons on coordinate geometry, but we are going to look at the circles part. So now I've just selected the aspect you need to know under the circle. So coordinate geometry, but we are going to look at the circles aspect. So in this lesson, we'll look at the definition of a circle, properties of a circle, then general equations of a circle, equation of a circle giving the endpoints of a diameter, then equation of a circle passing through three given points, equation of tangents and normal to a given circle. Then we have some special cases of tangents coming on board, and then intersection of a line and a given circle. Then we also look at loci or locus. So this is the aspect you need to know under circles when it comes to coordinate geometry. So without wasting my time, let us move on to the definition of a circle. But before that, let me draw my circle. Someone will say that circle is a round object, for which I beg to differ on that. There are so many definitions you can actually generate from the concept of a circle. But the major definition, which is well accepted, is a circle is simply a plane figure bounded by an arc which is equidistant from a given point known as the center. So you can note it down. Kindly write it down. A circle is a plane figure bounded by an arc equidistant from a given point known as the center. Yes, this is how you can define what a circle is. It's simply a plane figure bounded by an arc equidistant from a given point known as the center. Now you realize that this arc that was drawn or bounded, it can also be made up of smaller points. There can be smaller points on this arc, whereby continuously it also forms the circumference. Therefore, you can also define a circle as a set of points. A circle is a set of points, or the path of points, or the path of points, on a plane, equidistant from a fixed point known as the center or called the center. Please, are you clear with me? So that is how you can define a circle. Either it's a plane figure bounded by an arc equidistant from a given point known as the center, or you can also define it as it's a set of points or the path of points on a plane equidistant from a fixed point called the center. So it means that we have set of points on this path, and these points are very close. These points are very close, and therefore these points connected together and being equidistant from the center, then we say it is known as a circle. So every circle has a given center. Please, are we all clear? Are we all clear, please? All right. So moving forward, since we are looking at the coordinate geometry aspect of a circle, before I dive into that, then we need to know some of the properties of a given circle. Please, I know you have an idea about it, so can you tell me some of the properties of a given circle? Even with the definition that I just gave, I have actually given you one of the properties of the circle, or one of the parts of a circle. So what are some of them that you do know? Properties or parts of a circle. What are some of them, please?
It has a circumference which sum up to 360 degrees.
Okay, so we have the circumference, very good, which is a complete boundary of the circle from the center. Yes, what else? It also has what? So we have,
Radius.
okay, so you've made mention of circumference. Sorry. Circumference. I heard of diameter. I heard of radius. Yes, what else? Yes, please.
The perimeter.
Did I hear perimeter? Perimeter will also be the same as the circumference. Okay, I heard of chord. I heard of chord. What else? Can you come again? Is it? Did I hear segment? Because I think the network, because of the network, I'm not hearing that clearly. Okay, so we have segments. We have the chord. We have the circumference. We have the diameter. We have the radius, and then we also equally have the center. They are a lot. They are a lot. They're actually a lot. So going to my next screen, maybe for a bonus for you, um one thing I want you to notice that, let me just copy the circle and then we just use it again. All right, so if you have a circle has been actually the part of a circle has been grouped into two. So the two major parts, we have what we call the lines, the arcs, and then the points. They form one part, and then the other part, we have the areas, let me put it that way. So lines that we can form on the circle includes the radius, it includes the diameter, it includes the chord, it includes tangent, and then you can also have the arcs, which is just an arc. Then you have circumference. Then the points we may have the center. So these are the group that gives you the lines, arcs, and points. The radius is simply a given line segment which connects the center and the circumference. The diameter is simply a line segment which connects 2 points on the circumference passing through the center. So that is the definition for a diameter. It is a line segment that connects 2 points on the circumference of the circle passing through the center. So we have our diameter here. This is our diameter. And then this goes for the radius. The radius is simply a line segment that joins the center and any point on the circumference of the circle. Then we may have a chord. A chord is also simply a line segment that connects 2 points on the circumference. A chord is simply a line segment that connects 2 points on the circumference of the circle. So that is a chord. That is a chord. Now, the diameter is a special chord because it automatically passes through the center of the circle. So you can also define the diameter as a special chord which passes through the center of the circle, and it is accepted. It's accepted. Now we already know that the center is just here. It's just a point, a fixed point for which the circumference goes round. So that is the circumference. And then an arc is simply part of a circumference. An arc is part of a circumference. So maybe if I have one point here, another point there connected, from this end to that, we say it is an arc. It is an arc. It is an arc. Please, are we all clear with the definitions and their respective arrangement? Okay, so let's with the tangent. So a tangent is simply a line drawn in space to touch the circumference of the circle at a given point. So this will be my tangent, a line drawn in space to touch a curve or to touch the circumference of a given circle. That is at a given point known as a point of tangency. Known as a point of tangency. So you can actually visualize a tangent when you place a ruler on probably a cylindrical object or a curved surface. Even though you may see the rule touching the whole curve, but the close point of contact is only one. It's only at one point. So that is what a tangent is. And the point whereby that line drawn in space touches the curve is known as the point of tangency. The point of tangency. Now let us come to the other group, which is the areas. So when some lines and arcs intersect, it gives you a region, a bounded region. And that bounded region is known as an area. That bounded region is known as an area. So you realize that probably we have a radius here bounded by another radius, then an arc. Now this region here created is known as a sector. It's known as a sector. So we have one of the areas as a sector. Sector. So you can define sector as a bounded region of two radii and then an arc. A bounded region of two radii and an arc. That is what a sector definition can be given. Then we also have what we call a segment. A segment is also an area. But when do we have this area being formed? When a chord and then an arc are bounded together, we have a segment form. So probably we can call this area here as a segment, a segment, a segment. And then, as I said, the area here is known as a sector. We have minor sector, and then the other part will be a major sector. A major sector will have an angle wider than a minor sector. Likewise, a segment, we have a minor segment and then we have a major segment. Any questions so far? And then the last one we can look at is a quadrant. A quadrant. So these are basically the areas found, basically the parts of a given circle. So we've known the definition, we've known some of the parts and then properties of a given circle. Now we are moving on straight to what we call the equation of a circle. We are looking at equation of a circle. Okay, so having my circle once again, then if we want to generate the equation of a circle, there are some very important parts which is needed to help you draw or to get the equation of a circle. And what are they? Since we are considering coordinate geometry, then it means at the center, which is fixed, you have some coordinates there, and we can call the coordinates A and B. Now, on the circumference, the coordinate system on the circumference may change from one state to the other. So we can consider it using a variable x and y, because x and y values may change, but the A and B are always constant, so it is fixed. Therefore, with the center and the circumference of the circle, the variables there, I can connect it with a straight line, for which what name did we give to that line? Yes, what's the name given to that line? The radius. Very good. So if this gives me the radius, let me use small r for that matter. If this gives me small r, then it means that with the center of the circle and the circumference of the circle, the set of points there, as well as the radius, I can link this up to form an equation simply. And how do I link it up? From our coordinate geometry 1, we found out that if you have 2 points on the circumference of the 2 points on a line, you can actually form the equation of a line. Do you remember that? If you have, yes, if you remember that, then that's very good. So it means that we can equally form an equation connecting these 2 points and then the radius. And how do we do that? Now we can ideally draw some perpendicular lines between the center and then that of the point on the circumference of the circle. And when we do so, it gives you a right angle triangle. I don't know if you can see it clearly. So we've generated a right angle triangle out of this. And therefore, the radius becomes what to the right angle triangle? The radius forms what of the right angle triangle, please? The hypotenuse. So it means that then we can go ahead and then write an equation over here with the idea of Pythagoras theorem. So with the idea of Pythagoras, with the idea of Pythagoras theorem, we can connect them. So how does Pythagoras theorem quote? It is the change in the x direction, change in the y direction, all squared equal to the hypotenuse squared. Do you remember that? Which is, let's say, a squared plus b squared equal to c squared, which is actually x components, y component, all squared equal to c squared, which is the hypotenuse squared. So we can actually consider s component. How do we generate the s component? Here we have x, here we have a. They form the s component of the coordinates. So that is going to give us x minus a all squared plus y minus b all squared equal to the hypotenuse squared. What is representing our hypotenuse? That is
Oh,
the r, so r squared. Therefore, this expression here gives you the basics to equation of a given circle. Without the radius and another point on the circumference of a circle, as well as the center, it will be very difficult for you to form the equation of a circle. It will be very
please, I have a
difficult.
question.
Yes, I'm listening.
Please, forming the a squared and the b squared, can we
Yes,
decide to make it a minus x and maybe b minus y?
very good. As long as yes, you can actually interchange it. But as I said, when you interchange it in the x direction, then it means you have to interchange it on the y direction as well.
Okay, thank you.
Yes. Yeah. So you can go further to expand this. You can go further to expand this. When you expand this, you end up getting x squared minus 2ax then plus a squared. When you expand that, yes, quote it for me. What are you going to obtain?
Y squared
Y squared.
plus 2by
Will it be plus?
minus 2by
It is rather minus 2by
plus
then
b squared.
plus b squared. All equal to r squared. All equal to r squared. Are you with me? Are you with me, please?
Yes, please.
So ideally, please listen to my choice of words here carefully concerning equation of a circle. Now, we've generated the equation of the circle having the center, having a point on the circumference, as well as the radius given. We can form the equation of the circle. And you can have it as this, or you can expand to obtain this at the end of the day. So now, when you rearrange the information, you can equally have it as x squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared equal to 0. Does it make sense? Just look
Yes,
at it.
please.
Yes, it makes sense. Good. So if it makes sense, then there is something so special about every equation of a circle. Whenever you see it, it should tell you that this is an equation of a circle. And one major characteristics is that for every equation of a circle, the coefficient of x squared and the y squared are the same. The coefficient of x squared and the y squared, they are the same. Here cannot be 2x squared and here will be 3y squared. No, never. always the coefficient of x squared and y squared, they are the same. So note it down. Very, very important. You have to note it down. I'll be giving you some of the properties later on, but let us move on. Then again, this becomes the general equation of a circle. You remember I told you that when it comes to equation of a line, we have the standard form of it and we have the general form of it. The standard form of it, then it means y has been made a subject in terms of equation of a line. The general form of it, everything is equated to 0. So when it comes to equation of a circle, you can leave it in the standard form, which is what I have here, or the general form, which is what I have here. Based on the expansion of the standard form, the general form becomes this. And it's been grouped into two parts. We have the highest power of the variable x and y to be 2. The highest power is 2. So for every equation of a circle, you wouldn't have the highest power as 3. That's another key property of equation of a circle. The highest power is always 2. And the coefficient of the variables x and y is always the same. It's always the same. Any question before I move on? Any question before I move on, please?
No, please.
All right. If there is no question for that matter, then when you go further, based on our equation of a circle, you can also group it into parts, and which is, these are numbers. A squared plus b squared plus minus r squared. It's actually what we call, they are numbers. So it's constant. They are constant values. And as I said, the x and y varies from one point to the other. Therefore, we have this a squared plus b squared minus r squared can be considered as, let's say, one particular group. And that group, we can represent it with a symbol known as C. A symbol known as C. A symbol known as C. So it means the constant C is equal to a squared plus b squared minus r squared. The constant C is equal to a squared plus b squared minus r squared. Note it down. The equation of the circle that I've generated has the center as A, B. That's the center. And the radius is R. The radius is R. Please, are you clear with me?
Yes, please.
All right. Going further, I'm going to put a switch on this expression that I've given here. I'm saying the center is A, B. The radius is R. But what if the center becomes minus G and minus F? What if the center becomes minus G and minus F? And the radius is still R. What is going to happen? Now, we had it as x squared plus y squared minus 2ax minus 2by, then plus a squared plus b squared, and then we have minus r squared equal to 0. So that was when the center was A and B. Please, I hope you remember that. That was when the center was A and B. So in this case, if the A and B are being substituted with negative G and negative F, what are we going to obtain? We'll have x squared plus y squared minus 2 into brackets minus G because the a is being substituted with negative g. Then x minus 2 times minus f, then y, then plus minus g all squared plus minus f all squared minus r squared equal to 0. So we finally have it as s squared plus y squared. Then what would we obtain here? Plus 2gx plus 2fy, then plus g squared plus f squared minus r squared equal to 0. Please, are you clear? So this expression here became a formula, a general formula for finding the equation of a circle when the center is known and then the radius is also known. When the center is known and the radius is known. This time around, the center is negative g and negative f. Please, are we all okay?
Yes, please.
All right. So I've shown you two formulas here, and for that matter, we are going to use them to work out some magic. We are going to use them. But I don't want you to be chewing formulas. I want you to understand and use them as such. So if you understood the first one, you can simply apply. If you understand the second one, you can simply apply. For me, I'll be very glad if you know all and then know how to use them. Very, very important. Because sometimes the formula becomes very fast when you are working with generating the center as well as the radius when the equation of the circle is given. You wouldn't go through so much stress to come out with the center as well as the radius. So it is good for you to know both of them. So this one and then what I had on the previous screen, it is good to know all of them. Can we move on? Can we move on?
Yes, please.
So let's take the first example. So given that, find the equation of a circle. I'll do one, then you also do one because you don't have my time. Find the equation of a circle given radius and center. So we have number one as with center, which is 5,4, and then radius is actually 5 units. And then number two, we have the center as 0, negative 3 on 2, and then we have the radius as the number 3 units. All right, for the sake of time, please let me do all that fast with you and then we can box on. Therefore, when the center is known, the radius is known, I believe it is very easy to apply x minus a all squared plus y minus b all squared all equal to r squared. I hope it makes sense.
Yes, please.
So in this case, our a and b values are represented as the center. So we are going to have x minus 5 all squared plus y minus 4 all squared equal to 5 squared, which is a radius squared unit. Then you expand and simplify. This is going to give me s squared, then x times negative 5 will give me negative 5x. Negative 5 times x will give me negative 5x again. So together it gives us minus 10x. Then Negative 5 times itself will give us positive 25. Are you with me?
Yes, please.
Good. Going further to the y, what will be the expansion here? You should know how to do this expansion easily. What are we
Y
obtaining?
squared
Y squared
minus 8
minus 8y
xy plus 16.
plus 16, all equal to 25. Good. Then you can regroup everything into the standard form, which is going to be x squared plus y squared, then minus 10x minus 8y, and then 25 and 16 put together. What are we having? Plus 25 plus 16 minus 25, all equal to 0. So finally we have x squared plus y squared minus 10x minus 8y. This and that would leave us with plus 16 equal to 0. So with the center as 5, 4 and radius 5, the equation of the circle is what I have here. Are we all okay?
Yes, please.
Yes, sir.
Good. Let us take the second one fast. So with the second one, still using the idea x minus a all squared plus y minus b all squared equal to r squared. Where did I say this came from? What idea was used to get this?
The Pythagoras theorem.
Pythagoras theorem. Connecting the radius, the center of the circle, and then the one point on the circumference of the circle. So with this, we are going to have it as x minus 0 all squared plus y minus negative 3 halves all squared, then equal to 3 squared. That will be leaving me with x squared plus y plus 3 on 2 all squared equal to 9. Now we can expand this. Now expansion of this, what are we getting? X squared plus, we'll have y squared, right? Yes, y squared. Then what else? Y times that will give me, okay, let's write it 3.5 y plus another 3.5 y. Then finally plus, that is 9 on 4, all equal to 9. Please, are we all okay with the expansion?
Yes, please.
Good. If that is cool, then we are going to have it as x squared plus y squared, then plus 6 on 2. 6 on 2 is the same as what?
Mm.
9 on
3.
4.
Pardon?
The 3 on 2 plus 3 on 2.
So 3 on 2 plus 3 on 2 will give us 6 on 2. And that will give you 3. So we have 3y. Then plus 9 on 4 equal to 9. Now we can leave the answer in a fraction form. So at this point, we need to multiply through by the fraction, the LCM, and the LCM is 4. So when you multiply through by the LCM, you end up getting 4x squared plus 4y squared plus 4 times 3, which is 12y, and then plus 9 equal to 4 times 9 is 36. My people, are you with me?
Yes, please.
I hope no one is confused as to the expansion and simplification we're making. So you can regroup everything and then finally have it as 4x squared. Please do this operation for me. 9 minus 36. Then plus 4y squared plus 12y. And then negative what?
27.
27. All equal to 0. So per our center being 0 comma negative 3 on 2 and the radius being 3 units, this is our equation of that circle. That is our equation of the circle. And with the properties we talked about respect to every equation of a circle, the highest power of the variable x and y is always 2. You can see it here. And the coefficients of the x squared and y squared terms are always the same. So the coefficient here is 4 and 4 here. When we come to our previous solution, the coefficient of the x squared and y squared in that equation of the circle is actually 1. And the highest power of the variable x and y is always 2. Please, are you with me? Are you with me?
Yes, please.
All right. Okay. If that is clear, then I'm so happy you've actually understood equation of a circle, how to generate it, and what means you need to actually use to generate it. I'm so happy for that. I'm so happy for that. Now, in this case, okay, any question, please?
No, please.
No question. Okay, good. If there is no question, then I want you to note this down before I'll give you some work examples to try your hands on. Because from here, then we are launching into the deep. And when I mean launching into the deep, whenever you are given the equation of the circle, you should be able to generate the center and radius of the circle from the equation of the circle given. So that's where we'll be launching into the deep. But before we do so, I want you to write this down. So the standard equation of a circle standard equation of a circle. We have if the center is minus g minus f, and then we have the radius as r, okay, radius as r, then we're going to use s squared plus y squared plus 2gx plus 2fy, then plus what? C equal to 0, plus C equal to 0, where C is equal to g squared plus f squared minus r squared. Please, I hope you remember this. It was on the other page. I hope you remember that. And in this case, from this expression, we can make r the subject. Making r the subject, then we are going to obtain it as a simple switch. And when I mean a simple switch, we'll move the r squared to where the c is, and the c will join will come to where the g and f are. So we're going to have it as r squared is equal to g squared plus f squared minus c. So r will finally be square root of g squared plus f squared minus c. Remember, I've told you what the c is. I've shown you how the c came about. Can I move on? Note that Note that in the standard equation of a circle, perhaps let me just move it to the top there. Note that in the standard equation of a circle, A, the coefficients of x squared and y squared are equal. They are equal. Then B, there is no term higher. There is no term higher than the second power. There's no term higher than the second power. Then C, there is no xy term. There is no xy term. My people, are you with me? So take note of this. Very, very important. So let's begin with some plain. Which of the following equations is not representing a circle? Which of the following equations is not representing a circle? So we have number one as x squared plus y squared plus 3y minus 5 equal to 0. Number two, I have it as x squared plus 2y squared plus 5x minus 3y plus 2 equal to 0. Then the last one, C, I have it as x cubed plus y squared plus 2x plus 5y minus 7 equal to 0. Yes, that's what I have. Then final one, I have, that's number 3. Number 4, I have x squared plus y squared minus 2xy plus 4 equal to 0. Great. So we're going to discuss it. We're going to discuss this one and then we box on. Which of the following equations is not representing a circle? So just glance through and then tell me which one is not and give me the reasons why. Yes, let's box on. Let's box on. Let's be active.
Number two is not.
And what's the reason why you are saying number 2 is not an equation of a circle?
Because the coefficient of y squared is not the same as the coefficient of x squared.
All right. So number 2, as you've perfectly said, is not equation of a circle based on the reason you just gave. Good. Yes, what else? What else?
So with the number three, is it x squared minus
Number 3 is x cubed plus y squared plus 2x plus 5y minus 7.
number three is not an equation of a circle.
And what's the reason?
Because the difference, they should all have the same exponent. I think it should be they should all be squared.
Okay. So in other words, what you imply is that the highest power of the variable x should be 2, right? Okay, that's good. So since you have a cubic power there, automatically disqualifies this equation to become equation of a circle. Yes, what's next?
Please, number 4.
Number 4 is equally not an equation of a circle.
Yeah,
Reason.
because because it has xy as a term, which is not a feature of an equation of a circle.
Perfect. Perfect. So I'm so happy you guys are actually getting the concept right. So this is not, and that is not. But the first one is a perfect equation of a circle. But the rest that I've ticked here, they are not. Please, any question on that? Any other question, please? We have barely some few seconds to go. So if you have any
No,
question,
please.
all right. So then if there is no question, then I'll give you some question based on what we've learned. I want you to try your hands on some questions for me. I want you to try your hands on some questions for me. And what do I have for you? Find the equation of a circle given the radius and center. So I have number 1 as the center to be 2 comma 3 and the radius is 1 unit. Number 2, I have it as center -3 0 and radius 10 units. Then the third one, we have the center as -1 comma 4 and then the radius as square root of 12. All right, so I've given you these 3 questions. Try our hands on them. In our next lesson to come, we are going to actually consider how to generate the center and the radius from a given equation of a circle. So that is our next topic we are going to look at. How to determine the center and the radius from a given equation of a circle. That's what we'll be looking at in our next lesson. So please make it a date and then don't be absent. I believe that will be the last time we'll meet before you write the quiz. So please don't be absent. Don't be absent. Thanks so much for joining the call. I'm privileged having you, and thanks so much for subscribing to my YouTube channel and also learning from that channel. I'm so grateful. God richly bless you and have a lovely day. Bye bye.